Here we're given a situation when Sam goes to a pizza place that sells slices. He gets 1 slice 30% of the time, 2 slices 40%, 3 slices 20%, and 4 slices 10%. Create a probability distribution for this situation. So we know the number of slices he can get are 1, 2, 3, or 4. If he gets 1 slice 30% of the time, as a probability, I'd move the decimal place 2 places and get that this occurs with probability 0.3. If you write it as 0.30, that's mathematically the same. In general, we just drop the 0, but it would be absolutely correct if you said 0.30 instead of just 0.3. That said, I'm going to drop the 0 from all of these. 2 slices I'm going to call 0.4 for 40%, 3 slices 0.2 for 20%, and 4 slices 0.1 for 10%. And now I want to double check that I have a valid probability distribution. All of these are between 0 and 1 when they add together. 0.3 plus 0.4 gives me 0.7, plus 0.2 gives me 0.9, plus 0.1 gives me 1. So we do have 100% of the events covered. Yes, this is a valid probability distribution. When I'm asked a question like, what's the most likely number for Sam to get? Here all that's saying is which number of slices has the highest probability. Since 2 has probability 0.4, the most likely number for Sam to get is 2. Also, I could say that 2 is the mode of this distribution. So we don't really normally refer to things in terms of the mode here, but the most likely number is the mode. C asks me to find the probability he gets more than 1 slice. To find that, I have to say what counts as more than 1. 1 is equal to 1, so it does not count. 2, 3, and 4 are all more than 1 slice. So I need to take each of their probabilities and add them together. So 2 is 0.4, plus 3 is 0.2, plus 4 is 0.1. That gives me 0.7 as the total probability that he'll get more than 1 slice. Find the probability Sam gets at least 3 slices. At least 3 includes 3. If he ate at least 3 slices, he could have eaten 3 slices or he could have eaten 4. Both of them count as at least 3. So the probability of eating 3 was 0.2, plus the probability of eating 4 was 0.1. So there's a 0.3 or about a 30% chance that he gets at least 3 slices. Part E asks us to find the expected value of x. Remember, expected value means the same thing as mean in this context. So it's really asking me, what's the mean of the table? To find that, I'm going to take each table entry and multiply it by its associated probability, then add them all together. So 1 slice is probability 0.3, plus 2 slices with probability 0.4, plus 3 slices with probability 0.2, plus 4 slices with probability 0.1. 1 times 0.3 is 0.3, 2 times 0.4 is 0.8, 3 times 0.2 is 0.6, and 4 times 0.1 is 0.4. If I add these all together, 0.3 plus 0.8 is 1.1, plus 0.6 is 1.7, plus 0.4 is 2.1. That tells me, on average, Sam gets about 2.1 slices of pizza every time he goes to get pizza. Now that we have this mean, we can use it to calculate the variance and standard deviation. So my standard deviation, or sigma squared, is going to equal the first data point, 1, minus the mean of 2.1, quantity squared, times its probability of 0.3. I'm going to add to that the next data point, 2, minus the mean of 2.1, quantity squared, times its probability of 0.4. I'm going to add to that 3 minus 2.1 squared times 0.2, and I'm going to add to that 4 minus 2.1 squared times 0.1. For this one, it's not going to be easy for me to do some of these in my head, so I'm just going to put it all in as one big calculation. Parentheses 1 minus 2.1 and parentheses squared, parentheses 0.3 and parentheses plus. Parentheses 2 minus 2.1 and parentheses squared, parentheses 0.4 and parentheses, plus parentheses 3 minus 2.1 and parentheses squared, parentheses 0.2 and parentheses, plus parentheses 4 minus 2.1, end parentheses squared, parentheses 0.1, end parentheses. When I add all of this together, I get 0.89. That tells me that the variance, or sigma squared, is 0.89 for this distribution. If I want to just find sigma, or the standard deviation, I need to take the root of that 0.89. When I do the root of 0.89 in my calculator, it gives me an answer of 0.94339. I'll call it 0.943. Again, make sure you're paying attention to however in Cengage they tell you to round, go to that number of decimal places.